Hi everyone, this is Burak and welcome to another episode of CodeIgniter from scratch. And I believe this is day 14 and our subject will be security. We'll talk about the security features that CodeIgniter framework comes with that we can utilize and make our web applications more secure. Um, so let's get started by installing CodeIgniter. I have an installation here and I set up my config, my base URL, my index page, blank, and I have an htaccess file to remove that index.php. And I took out my application folder out of my system folder. This is the standard stuff we always did before for installing CodeIgniter. And now it should be running. If I go to my application URL, I get the welcome page, everything seems fine. So let's get started by talking about uh, the first thing I want to talk about is inside the config file. And if you scroll down, you will see that there's a setting called allowed URL characters. Now this allows you to set what's allowed in your URLs. So this is a regular expression, and for example, A-Z means A through Z. Um, and there are a few more characters besides letters and numbers that are allowed, and everything else is not allowed. So, for example, our default controller is welcome. So if I were to pass welcome foo, I'll get a 404, which is fine because there's no controller method named foo right now. But if I were to put, let's say, star foo, star or asterisk is one of the characters, or rather it's not one of the characters that are allowed. So if I open this page, now you will see there's an error instead of the 404, and it says there are disallowed characters. Um, so let's see if we can have another example for this. I'm going to create a controller under the controllers folder, a PHP file named test.php, and it's a test extends controller. Now let's do some tests. Allowed cars is going to be our controller method name, and it's going to take a parameter and echo out that parameter. You passed me param. Okay, now if I open this URL, test allowed cars, and foo becomes the argument to this controller method, and it's being displayed as you passed me foo. So that's fine, but if I add star like this, again, it's not allowed. So let's say you want to be more restrictive. For example, there are characters like tilde, colon, things like that that are right now allowed. So it could be 1, 2, 3, tilde, colon, 4, 5, 6, something like this. It is allowed. And let's say in your application you don't want these characters. You only expect normal letters and numbers and underscore dash, and that's it. So you can just modify this, remove a few of these things and tilde, and there's a backslash before the dash because this is a regular expression and you have to escape that. This is not actually the backslash character. So this is a more restrictive setting right now, and this will give an error. So it's only gonna be like 1, 2, 3 underscore 4, 5, 6. That will work. So this is like a security layer that's in addition to everything else to prevent unwanted data to sneak into your controller methods. So it's not an I wouldn't call this an exactly a filter, but it's like a additional layer that might benefit you. So it's something that's good to know. I will just undo these changes and set it back to the default. Okay, now we can talk about the next thing. I want to talk about encoding passwords. If you remember, I believe it was day 6 of this series. It was one of the episodes that Jeffrey Way did. He was encoding passwords before storing them in a table. So if I'll show you some screenshots from that video. You see that there's a membership table in the database and its password field, and this field is set to varchar32. And the reason it's 32 is he wanted to store the passwords as MD5 encoded strings, which are always 32 characters long. So, for example, when he inserted a record, it looked like this. It was a 32 character long, like a hex string. 0 through 9, A through F are the possible characters. And this is generated by calling the MD5 function around that string, in this case the password. So in case you don't know the reason passwords are stored in encrypted format, it's very commonplace, and it's because in case a database gets stolen, uh, the passwords are very sensitive information, because a lot of people tend to use the same password for different accounts, like their emails, their bank accounts. So if their passwords get stolen in one place, it might affect their other very important accounts. And you don't want to have that liability as a web application developer. If you're storing people's passwords, better make sure that you only store them in encrypted format so they cannot be reversed to their original passwords. I'm going to do a quick example of the MD5 here. MD5 test. Again, this is just like that example from the other episode, using the MD5 function that comes with PHP. And just do MD5 test. Let's say again foo. That string foo is, I'm sorry, that string foo is turned into this 32 character string. It could be something else like a number. You'll see it's a totally different string. And if it's changed by even the smallest bit, like let's say I changed the 6 to a 7, and the entire string, the encrypted string, is totally different. And normally it's not possible to go from this encrypted string back to the original password or original string. But this MD5 algorithm has been around for several years, and some people argue that it's not the safest way anymore. So there are better encryption methods like SHA1 or SHA1, and I'm going to show you that now. Function SHA1 test. Again, just echo SHA1 pass. So instead of MD5 test, I'll do a SHA1 test. You'll see that the result is very similar in terms of it's a hex string, very random, and but this time is 40 characters long. So make sure that if you want to store SHA1 encrypted strings, store them as a 40 character long varchar fields, or just character fields instead of varchar. And SHA1 function was added to PHP, I believe, at one of the PHP 4 patches. And since CodeIgniter is compatible with PHP 4, they made it so that in case they have an older PHP 4 version before the patch that added the SHA1 function, they made it available in the encryption library. So I'm going to do another test here to show you that example. So if you want to be compatible with those early PHP 4 servers, then you can load the encryption library to do the same thing. Library encrypt. That's how you load the encryption library. And to use that SHA-1 function, just do encrypt SHA-1 pass. So if I do SHA-1 test 2, I get the exact same string. It's using the encryption library's implementation of SHA-1. So this is going to be more PHP 4 compatible. Okay, so that's that. The next thing I want to talk about is encoding, but this is going to be a reversible encoding. So we're going to have a string to start with, then we're going to encode that into another string, and which will be again like gibberish, nobody can understand, but we will have a way to decode it. So let's see that function encode. Again, you can use this to store information, and but this time this is used if you want to be able to get that information back. SHA-1 is, for example, not reversible, but this encoding will be reversible. So let's say you have a message, and this is a secret message. So let's load the library again, and this is part of the encryption library again. And this time, I'm going to encrypt and encode the message. So the function is encode under the encryption library. And let's echo this. So open this in the browser, test encode. Okay, you'll see it's a quite long string. So this is the encrypted version of this is a secret message. And according to the documents, it can be like 2.6 times as long, or even this looks even longer than the original string. So if you're going to store encoded strings like this, make sure you have plenty of space. And I mean like proper sizes in your database table fields. So to decode this, we're just gonna run the reverse, and very simple. Now I'm loading the encryption library again, and instead of encrypt encode, I'm going to do decode. I'm going to decode, let's say, my encoded message, and the encoded message was in this case that I'm going to copy paste that into encoded message. Okay, now when I do this, I should get back the secret message. So I'll go to decode. Yeah. But now, let's say you encoded a message like this, but somebody else who has CodeIgniter installed or has the same algorithm available can decode it, right? So it's not exactly secret if somebody else can install CodeIgniter and just run the decode function on the message. To make sure that it only you are the one that can decode it, you need a key. So this key is like a way to lock it and unlock it. So let's copy this encode function. Let's say encode with key, and I'm going to pass the key as a parameter actually. So this is a secret message. So this time we're going to pass the key to the encode function, and that will be the second parameter of the encode function. And there will be a decode function. Again, I'm going to copy this, decode key, and the decoding will be done with a key also. So um, let's see what the encoded message will be with a key. Encode with key, and let's say our key will be hello world. Alright, this is the result. I'll take that and put it here to decode in my decode with key function. So let's say I don't know this key, which can be anything, but I have this string. So if I try to decode it with another key, I will not get the original message. I'll get some other random characters. So I can keep trying with different keys, and I will not get the message until I use the same key that it was encoded with. So I'll type hello world, and I'll get the secret message back. So this is a way for you to lock and unlock the encryption on the messages. Okay, let's move on to another subject, and this is going to be about SQL injection. This is a common security hole found in web applications. If you're not filtering user input properly before using it in a query, you can have issues. Let's say we got some user input like a form submission, and there was a name submitted, and then we're going to have a query that searches by that name. So our query would be let's say select star from users where name equals name. Now this might look okay, but it isn't, because in this case there's nothing wrong with this string. But if the attacker knew that our query was not being filtered like this, they could add malicious code like, close the single quote, that's, closing this single quote, and then add like an or statement, and name equals admin. So now the search will return either that user or the admin. For example, depending on where this query is being used, it could give people access to stuff that they're not supposed to. This is just one small example. So unsafe. So in a raw query like this, a standard method of escaping would be using the PHP function named MySQL real escape string. Okay, and close the quotes. Alright, so I'm gonna put this in a new line. This will ensure that if there are characters like this single quote or other things that can invoke unwanted queries, this will escape those and give you a safer query. And another option is using the database library's escape methods. So if you load the database library, you can do the same query like this, but instead of MySQL real escape string, you can do this db escape. So that's a way to escape it. And another one is actually for strings, you might want to use str, and there's one with detection of the variable type. So instead of escape string, if you do escape, it will determine if the passed variable is a string or a number. If it's a string, it will put single quotes around it automatically, so you wouldn't need them in your raw query here. If it's a number, it doesn't put the quotes around it, so this is the syntax you would use that. And another one is in case you are using a like query. For example, if this is a name like with like percent signs around it, you have to escape with the escape like str. Now this is all for raw queries, but if you're using active records, you don't actually have to worry about these, which is a nice thing about the active records class. So here, no escaping needed if you use this db like select function from users where name equals name. As you can see, the string name here is passed as a parameter to the where function, and the where function takes care of the whole query building part of this active records class, takes care of the escaping for you, so you don't have to worry about calling these escape functions when you're using active records. Alright, and the next thing I want to talk about is input filtering for cross-site scripting attacks. This is also a common security threat on today's web applications. What is cross-site scripting? It is one person entering information to a website and that information being displayed to another person, which can trigger things like JavaScript code in that other person's browser to steal cookies and other information and or make them do things that they didn't mean to. For example, let's say you have a website where people can post comments to, and one person posts a comment, but in that comment they insert some JavaScript code, like a way to do this cross-site scripting attack. And once they enter that code, that comment is displayed on the website to other people. And when the other people look at it, if that JavaScript code is not filtered properly and gets executed in the browser window, then that can trigger many unwanted things. So there's a way to, there's always a way to filter inputs. When you insert them to database records, you can filter them. When you're displaying them, you can filter them regularly. But there's also cross-site scripting filters to prevent these common threats. And I'm going to here XXS filter as an example. For instance, is input post comment. So let's say you had a form with a comment and somebody posted it, and this is how you get the comment. And you can do all the filtering you want, storing it, but an additional layer of filtering you can do is by passing the second parameter to true, which triggers the cross-site scripting filtering. And there's also a way to manually filter strings. So let's say you have a string and you just want to use that functionality on that string, and this is not like a post input. So you can run this input XSS clean on the string, and now you can have a clean version of that string. And so yeah, and you can also enable this globally. For example, normally this would be like this without the second parameter, right? This can be filtered by config. And what I mean is, if you go to your config.php file, you can scroll down. I think it's towards the bottom. Yes, there's global XSS filtering, which is set to false by default. So if you set this to true, now this line will act just like this line. So it will be filtered by default. So enough about XSS filters, and now let's talk about some output filtering. So anytime you want to have an output that contains a string out of your, let's say, database, you want to escape it before displaying, because if that string contains any kind of HTML tag, it can break your HTML page. For that, you use the HTML special characters function. And this is a PHP function. But let's talk about what CodeIgniter can do for you. When you're outputting a anchor tag, let's say, again, you would have to escape the URL normally if it's coming from a database or something to make sure it doesn't contain any special characters. But if you use the anchor function and pass the URL, you don't have to worry about escaping, as CodeIgniter will take care of that for you. Automatically filtered. Now, let's say another example would be the form helper functions. A input tag could look like this, and this can get very long. Input type text. Let's say it's named name, and the value. If it's going to have, when the form is posted, you want that to be displayed back again, so it will be post name. However, as I said, you want to escape any kind of user input that's going to be displayed within your HTML. So you would have to call HTML special characters. But there's another problem. If this post name does not exist, if the form was not just posted, there will be a PHP notice displayed, like an error. So you don't want that to happen, so you have to do is set before doing this, post name. So you have to go through all of this to display an input field. Meanwhile, you could just use echo form input name and set value for getting that post variable. Again, this is automatically filtered. As you can see, you don't have to do any kind of HTML special characters filtering. So you can see that CodeIgniter, or using any kind of framework, helps you out and taking away the responsibility of some of the filtering and escaping. Okay, next thing I want to talk about is session security. And if you use CodeIgniter's session library, you should be aware that by default the settings are not very secure, and I'm going to demonstrate that here. This session sets user data. For example, let's say you have a login system where once a user logs in, you set a user ID in their session, which is very common. And if you do this with PHP's native sessions, you know that this is stored server side. The user can't mess with this ID number. So let's say the user has an ID of 2, but there's also an ID of 1 in your users table, which is like an admin that has all the powers, but this user is not supposed to have those powers. And once he logged in, he has 2. So if this guy had a way of changing this 2 to 1, that would not be good for you, because then he would be able to gain access to everything. So let's see how this can be an issue. Test session. Okay, it seems fine. The person's session user ID is set to that, and let's create session read user ID. First, let's load the session library. This load, sorry, this session user data, user ID to get that. So if user ID equals 1, you have all access, and else you have limited access. So let's see, session read, you have limited access, user ID that. Let's see if we can hack in and change this user ID. So if I look at my cookies through Firebug, you'll see that the cookie data is containing the user ID 2 in a serialized PHP variable here. So this is the security weakness I'm talking about. And there's a MD5 encryption of this string here, but it's not good enough because I can do the same. I can take this string, change it, and encrypt MD5 encrypt it and update the new value. In fact, I'm going to do that right now. So I'm going to update this with this string. You see the user ID is now 1. Update my cookie and refresh this. Now you have all access because it sees that my user ID equals 1. Or I can just verify that here. So I mean, it's not important how I did this, but I just want to demonstrate that it is possible to update the session data from the client side, which is not a good security situation. So what can be done? You just want to enable here in your config file. You can either enable database storage for sessions so that the session data is not stored on client side but stored on database side instead, or you can start using an encryption key, and this encryption key will modify this string at the end of the cookie, so that can only be known on the server side, so the user will not be able to put the right encryption here. So those are your two options: either putting an encryption key, which can be anything, it could be random characters, or enabling database storage of sessions. So that's that, and the next thing I want to talk about is errors. And this is very simple. Let's say you're calling a function that doesn't exist. So to demonstrate this error, I'm going to open test error. You'll see that it's outputting this error to the browser. Now you can see the path of the script and the line number. So this is some information about your scripts, and normally this is not. This is considered a security weakness, and you don't want to be displaying this kind of information to the browser. So what you can do is open open index.php of CodeIgniter, and you will see that there's a little paragraph here that talks about it. So instead of setting error reporting to all, you can set this to 0 to stop reporting errors to the browser. So when you refresh, the error is gone, and internally you can handle the errors. And next thing I want to talk about is having secret or private methods in your controllers. And that is done by, let's say you want to have a secret method, right? Echo you called secrets. So this method is available from the web, but you don't want that to be available. You want to be able to call it from within your code, but not from the web. All you have to do is put underscore in the name. So this will prevent this to be called from the web. So this will give a 404. And even if you try to put underscore in the URL, you will still get 404. CodeIgniter will not let it display that function. So that's how you can create methods that they're not supposed to be accessed from the web for security reasons or for other reasons. And I believe that's all I want to talk about for the security features today. And I hope you learned a few things. And I'll see you next time. Bye.